Okay, for this teaching worksheet is this teaching worksheet is the start of integration. So the whole idea of integration is directly opposite of differentiation. Okay, so there will be a lot of concept that we will make use based on differentiation, but we are working backwards. So in integration, a lot of time you'll be given dy dx, and then you are expected to apply some formulas to get back to the original expression of y. Okay, so the first part is I'm going to introduce the symbol first and the basic idea. Okay, so if you recall from your differentiation, if you are given an expression, this expression, and I ask you to get a dy dx, by now it will be a very simple process. You just do a bring down power minus power. Okay, so now we're going to reverse the idea. So now we're going to reverse the idea. Okay, but when we reverse the idea, so now let's say I give you a dy dx is equal to 6x. So in a reverse idea, that means, right, I will know that it actually comes from 3x squared plus a number. So you realize that I didn't put a 5 there. Okay, the reason because it may not be a 5. It can be any number. Because any number, if you differentiate, you actually get a 0. So if let's say I'm not getting a 5, so just a generic constant, I will still be able to get a dy dx equal to 6x. Okay, so there is this idea that when you integrate, there will be a constant. The constant is not known because differentiating constant actually give you a 0. So in a way, when we integrate, right, when we integrate back, there may be a constant that we don't know. Will you be asked to find a constant? Yes, they will ask you to be finding the constant, but they will provide you with some information. So later on, we will be looking at some questions where you will learn how to find the constant. Okay, so right now you get the idea of integration first. So it's the reverse of differentiation. Okay, and the symbol will be something like this. So I show you the structure first. So basically we got a curly tail symbol, and then we got a dx symbol. So in between these two symbols, right, it's like we are putting a dy dx here. So can you see this one is the dy dx? So can you see it's actually the dy dx? Okay, and then it will be equal to the expression for y. So can you see this whole thing is y, and then this is the dy dx. So in a way, I will always tell students, when you present your integration, it's like a fork and spoon. So the integration sign and the dx is like a fork and spoon. Then you put on your plate, you put your dy dx. So that is the symbol for integration. And this integration, okay, so in this case, right, this part here, integrating 6x with respect to x, it is called indefinite integral. Okay, so why is it called indefinite integral, and so what is the opposite of it? So later on, subsequently in, I think, one of the teaching worksheet, you will start to learn some integration that has some numbers here. So when integration comes with number, we will call it definite integral. So anyway, later on, there will be a teaching worksheet that focus on definite integral, because this will lead you to one of the application of integration. So at the moment, you will just be learning indefinite integral. So when you do indefinite integral, there will be a plus c. Okay, there will be a plus c because when you integrate an expression, they may be an unknown that we are not so sure. Okay, and the subsequent part we'll be learning how to find the unknown. Okay, so right now we're gonna go the reverse process. How are we gonna go the reverse process? So if you recall your differentiation, the differentiation we got bring down power minus power, we have differentiate constant, and we also have product rule, chain rule, quotient rule. Okay, but in integration, we wouldn't have product rule, quotient rule. Okay, we only have very, very basic formula. So the very, very basic formula is to integrate a constant. Okay, so formula number 1 is going to teach you how to integrate a constant. So what is the meaning of integrating constant? That means, right, your dy dx is a constant. So look at this part here. Okay, look for your fork and spoon. So can you see these two parts is the fork and spoon? So whatever that you are placing in the middle of the fork and spoon is your dy dx. So if your dy dx is a constant, so what will be your y? You can do a mental. By now, I think it's quite easy for you to do a mental. If your dy dx is a number, so for example, your dy dx is like 7. Okay, you think backwards a little bit, you will expect that it comes from a 7x. So differentiate 7x really gave you a 7. Okay, but again, of course, there's an unknown here. I wouldn't know whether there's an unknown or not, because if I differentiate this unknown, anyway, I'm going to get a 0. Okay, so if you think backwards, it's going to be like this. That's why the formula for integrating a constant will be kx plus c. So this is the formula. So when you integrate a constant, you think backwards, it comes from kx plus c. Okay, and then for formula number 2, you are going to learn how to integrate things with x. So previously, okay, so let's explore this part first. So this will be my dy dx. So what will be the y here? Okay, so you can think very simple dy dx. So for example, maybe we get a 6x squared. So for those of you, if you are fast enough, right, you can think backwards. Numerically, you can try to think backwards. So you will realize that it actually comes from 3x, 2x cubed. It will come from 2x cubed. But they may be an unknown number. Okay. So I think if you successfully manage to get the 2x cubed in your head, that means, right, you are kind of like returning the power. Because during differentiation, you bring down power, you minus power. So in the integration part, right, you are going to return the power. You're going to return the power. So previously you subtract 1 from the power. So now you're going to return the plus 1. And previously you multiply by the bring down power. So now you're going to divide by the new power. Okay, so if I try to use this, if I try to use the formula, so I add a power, I divide by the new power. So that's exactly how I gotten my 2x cubed. Can see? Okay, so these two formulas, right, basically is teaching you how do you integrate constant and how do you integrate simple x, which is opposite of bring down power minus power. So because you are very limited by the formulas, so there will only be these two formulas, and later on there will be a third basic formula, and that's all. You are not going to have the reverse of a product rule. You are not going to have the reverse of a quotient rule. Okay, so I'm going to show you how we are going to use the two formula and how the correct presentation should be like. Okay, so in this case, yeah, you are given dy dx, and I'm supposed to find an expression for y. That means where does the dy dx come from? Okay, so very simple. Okay, y will come from integrating the dy dx. So the correct notation will be something like this. So it's something like this is your plate. Remember just now what I said? Your plate is your dy dx, and then you place your fork and spoon. So that is a presentation. Okay, and then you integrate one by one. If you look at this one, it looks like formula number 2, and this one, it looks like formula number 1. So just like differentiation, you can integrate one by one. Sorry, differentiation, you differentiate one by one. In integration, we also integrate one by one. So if I apply the second formula says you return a power, divide by new power. Okay, then integrate a constant. According to the formula, is just 3x. So you are integrating twice, but you do not need to put 2 constants. You just put a generic constant will do. Okay, and from here you simplify. So you get 2x4 over 4. And then here you actually get a half. So that is the correct expression. Okay, so anyway, you can do a double checking because I believe that you are faster in your differentiation than your integration at this stage. So you can do a quick bring down power minus power. So if you do a bring down power minus power, sorry, I read something wrongly. So it's supposed to be a 5. I don't know why my 5 become a 3. So it should be a 5. So the C that you got, if you continue with the differentiation, anyway, it's going to get you a 0. Okay, so that's how we use the formula. Okay, so subsequently, you find that what happened when you got a square root and this kind of fraction. So we cannot help. You still need to engage some of your indices. So you got to simplify your indices first. Square root is a power half. Fraction is a x minus 2. So if I would like to get expression for y, I got to be integrating this. And both of them contain x. So obviously I need to apply my formula number 2 here. So I'm going to apply my formula number 2 one by one. So when I apply my formula, I will return the power, divide by the new power. Same thing, I return the power, I divide by new power. So only one constant. Okay, then simplified it. It's not going to look very nice. So you are dividing by 3 over 2. So you realize that it doesn't look very nice. So how am I going to simplify it? So usually this is what I will do. So look at this as a coefficient 1, and this is the divide. 1 divided by 3 over 2. If you punch calculator 1 divided by 3 over 2, that will give you a 2/3. So I will have gotten a 2/3. Okay, then subsequently, negative and negative will give me a plus. Okay, so I'm going to get my final answer. So my final answer is just 2/3 x to the power 3 over 2. So this is a negative power. So use your indices rule and change it back. So that will be my expression for y. Simply because I applied formula number 2, but because of the fraction, it gave you quite a complex expression. Okay, so in part C, we still have more indices. Okay, so I'm going to, for some of you, if you're a little bit weak in indices, okay, I hope by now you got used to You realize that differentiation, you keep using indices. So when it comes to integration, it's the same thing. And it's usually that few indices rule. So for example, here, square root is a half. Here, this is a half times the 1 over x cubed. So if you look carefully, it's 2x minus half. And then that will be minus half. This whole thing becomes the x minus 3. So you got to perform your indices very well first for your dy dx. Subsequently, in order to get y, you integrate your dy dx. But you integrate your dy dx that you already done your indices properly. So obviously these two terms, it contain x. So you'll be using formula number 2. So what happens when you use formula number 2? You add a power, return the power, divide by new power. Return a power, divide by new power. And then you just add a c. It looks a little bit complex, but if you do very step by step, it's not going to be so bad. So if you try to do step by step, you realize that it's not so bad. So subsequently, what will I do here? Okay, subsequently, okay, 2 divide by half. So I will punch calculator, 2 divide by half. That will have given me a 4. And x to the power of half will have given me a square root x. And then negative and negative would have given me a plus. Plus what? 2 times 2. So I will get a 1/4. And this part is your indices. So this part will have given me a 1 over x squared. So my final answer will look like this. You realize you spend more time simplifying indices than the actual integration. And do you realize the moment I apply the formula, so the moment I return the power and divide by the new power, that is the application of the formula. My fork and spoon disappear. So I started off with the fork and spoon. The moment I return the power divided by new power, the fork and spoon disappear. So all the previous situations are all like this. So I initially have the fork and spoon to indicate that I'm integrating. But the moment I apply the formula, the integration sign disappears. Okay, so take a look. So that is just pure formula 1 and formula 2. So there is quite a bit of indices here. And it's not so easy sometimes because you have spent quite a few months, maybe 1-2 months on differentiation. So suddenly you've got to reverse it. So sometimes unknowingly you may be still doing a subtraction in power. But right now you actually got to return the power and divide by the new power. Okay, so that will be the basic 2 formulas to start you off for integration, which is the reverse of differentiation.